Hey, what is going on everyone? I'm Wicked. Welcome back to the Block from Hero to Wizard tutorial series. In my previous video, I showed you how to start designing, sketching and separating the features of a new application right from the most basic concept, the idea inside your own mind. Today, we're going to put everything to practice and code the entirely redesigned Flutter counter app. If you think this tutorial is too basic for you, I highly recommend that you still stay and watch it because you'll be surprised on how many things you'll learn. So without further ado, let's get right into it. The first thing we'll need to do is to download the block architecture startup project zip from my GitHub page. This repository, as its name is implying, provides the already created folder structure, aiding towards a clean and structured start in every project I'll build from now on. I just wanted to let you know that any pull request that could improve the structure of the project is really welcome, and I want to say thank you to everybody who already contributed to the repository. Therefore, open the project inside VS Code, let's get to work, because man oh man, we have a lot of stuff to code. We'll start by setting up our routes right into our app-router.dart file. As you can see here at the beginning of the class, there is a place to write down all the routes and assign them a straightforward variable name, so that whenever you'd want to use this endpoint inside your application, you'll be 100% sure that it's the exact string. On the other hand, having to manually type the string on the route could result in typos, and route typos could lead into route exceptions, and we definitely don't want that. So we know from the previous video that the redesigned counter app will benefit from only one screen, the counter screen. Therefore, let's rename this route to counter. Quick tip: when you want to rename a specific part of your code, and you're going to do this a lot, it's recommended that you do it by pressing F2 on your keyboard, so that it will modify all the occurrences inside your project. You might fine-tune the renaming action by pressing Shift plus Enter to let VS Code scan and know which specific occurrence will be renamed. As you can see, in my case, there are 3 occurrences I can rename. I want to rename all of them, so I'll click the refactor button. We'd also want to change the structure of the folders a little bit, since right now we don't want to push a home screen page onto the navigation stack, but rather a counter screen. So we'll rename the home_screen folder to counter_screen, and also fix the upcoming import errors. At the end, we should probably have something like this. Every time the navigation feature of Flutter will receive the /counter route endpoint, the counter screen will be pushed right onto the navigation stack. We'll also have to modify some of the string constants by renaming them appropriately to the counter screen context. As another quick tip, you can see right here, I have extracted every string into a separate folder so that I can easily modify them when I need to. This will come in handy when projects get really large, because when you'd want to modify a string, for example, you won't have to dig into the entire project to search for it. It will also help with internationalization on future projects, when you'd have to translate every string to multiple languages. So everything right now seems like it's a good time to run our project for the first time, right? If we do that, we'll find out something really intriguing. There has been a route exception thrown in our app. It was thrown right from within the onGenerateRoute function. But why exactly was that? We know that we properly provided the /counter endpoint as the initial route. How couldn't Flutter find it? Well, the problem is more complex and you need to understand it so that you won't be surprised again in the future. You see, whenever you pass an endpoint containing backslashes to Flutter, it will push every single screen mentioned in that endpoint one after another, and that is including the first backslash representing the home route. So, for example, if you have a route called /screen1, /screen2, /screen3, Flutter won't push just the screen3 inside of the navigation stack. Instead, it will push the following routes in this specific order: the first backslash, the /screen1, /screen1, /screen2, and then /screen1, /screen2, and /screen3. So you would have the home screen, the screen1, screen2, and screen3 pushed inside the navigation stack one over another right in this order. Therefore, in our case, it was not the problem that Flutter didn't recognize the counter page, but rather that it didn't know what to do with the /route, since it wasn't assigned to anything in our onGenerateRoute function. All we know is that our home route is actually the counter screen. So what can we do to fix this issue, you may ask? Well, we'll just need to rename the counter endpoint from /counter to counter. If we save and restart the project, you'll see that everything worked out perfectly and now our initial home is actually the counter screen. Now, let's focus on the theming part of our app, shall we? Previously in this series, we decided that the revamped Counter app should be able to switch between light and dark themes based on whether the system was set to day or night mode. To do that, first and foremost, we need to create both themes. There is a separate place to do that in our folder structure called themes. Here, we'll create two theme data variables, one for the light theme and one for the dark theme. Now, let's focus on the colors we'll use for both themes. As I mentioned previously, I would like for the light theme to be more of a frosted wintry one, predominantly white, so let's create the light background color and design it one of the white colors I got previously from colorsinspo.com. Now, every theme should be actually formed out of multiple colors, but the most important ones are the primary colors and the secondary colors. The primary color is, as its name is implying, the main color you'll notice whenever you'll open up the app. This can be tightly related to human psychology. For example, banking apps may use a blue primary color since blue signalizes trust. I want my light theme to denote purity, so I will set the light primary color to the same light background color. The secondary color, on the other hand, is also known as the accent color. The accent color is primarily used for buttons in order to create contrast in the app. Since I want the light theme to be a muted wintry one, I want the accent color to be of a blue-grayish one, more specifically a lighter shade of gray. Don't forget, we also want to have some moving particles on the background of our app, and in the case of a light theme, I want them to be of a muted white, barely visible. The color I found to fit this requirement the most was this one. Now all we have to do to create a dark theme is to kind of mirror the light theme in an inverted way. So if your light theme is predominantly white with some light shaded blue-gray accents, then the dark theme should be predominantly dark gray with some darker gray accents. We set up the colors, now it's time to link them with the appropriate themes. We set up the brightness so that Flutter will know how to convert text color in case of a light or dark theme. As we know, the text on the light theme should be black and the text on the dark theme should be white. The rest assignments are self-explanatory. Along with the current theme of the app, we should not forget that we also want to modify the status bar and the navigation bar accordingly so that they both integrate well with the app. Therefore, we'll create a static method called setStatusBar and navigation bar colors, taking a theme mode variable as a parameter. We'll use that theme mode type to decide how we're going to set the colors to our status bar and navigation bar. We'll do that by calling the system_chrome.setSystemUI_overlay_style, inside of which we'll pass a systemui overlay style. This one comes with a bunch of parameters we can tweak in order to achieve what we want. For example, I want the status bar to be transparent, so I'll set the status bar color to colors.transparent. The status bar icons should be white when the theme mode parameter is set to dark and black when it's set to light. The same applies to the navigation bar icons. The navigation bar, on the other hand, can't be set to colors.transparent since it doesn't have anything to render below it. The app screen ends right above it, so the result would be a black color. So we should set it to match the color of our current background color instead, according to the theme mode. Now, how about we test the functionality of the light and dark theme? In order to do that, we need to link our themes inside the Material app widget. Fortunately, they are already linked in my startup project, but if they weren't, all you need to do is to set the theme parameter to apptheme.light and the dark theme to apptheme.dark. But how does Flutter know when to change between the light and dark themes? Well, it doesn't. You'll need to specify whether it should render the light or the dark theme. You can do that by mentioning the theme mode parameter. So, as you can see, if we set the theme mode parameter to thememode.light, the app will render in a light theme. But if we change it to thememode.dark, the app will render in a dark theme. To understand the functionality of the Flutter theming even more, we should modify the current UI a little bit. Inside the counter screen, we won't be using an app bar, so we can easily remove it. Then we'll wrap the entire center widget in a container and we'll set the background color to our theme's background color. You can access the current theme's background color by calling theme.ofcontext.backgroundColor. This is where Flutter magic comes into place. You may wonder, well, which background color will Flutter provide here? The light one or the dark one? Well, it depends on what theme is set as the theme mode parameter we discussed previously. If it is set to theme mode.light, as you can see, the container background will be white. But if it's set to dark, the background will switch to the dark gray color we set up as the dark background color inside our app theme class. Having this in mind, we can deduce that this theme mode parameter is the one that will need to make it change dynamically depending on whether the system theme is set to light or dark mode. Why shouldn't we take care of this now? And as you can observe from my workflow, this is the way you should advance from one topic to another. Start with something, finish it, and then advance with related topics from that point. So we took care of the themes. Now let's take care of how to rebuild our UI based on whether the theme of the device is set to light or black. In order to do that, we would obviously need to create a ThemeCubit, since dynamically changing the theme of our app represents a feature of our app. This ThemeCubit will only emit a single type of state, namely a theme state. This theme state will contain a variable of type theme mode. This variable will contain the current theme mode linked to the current theme mode of the device the app runs on. So if the device is set to day mode, the theme mode field will be set to theme mode.light. And if the device is set to night mode, the theme mode field will be set to theme mode.dark. We also don't need to forget to set up an initial state for the ThemeCubit, which I'll set to a light themed theme state. This doesn't really matter since it will be overridden by the system theme anyways. But when will this ThemeCubit emit a new theme state? Well, first of all, we need to create a qubit method that will be responsible for emitting a new state, in which we'll check whether the current system theme is set to light or dark mode. And then, based on that, we'll update the UI by emitting a new theme state with the appropriate theme mode parameter. We'll call this method updateAppTheme. In order to check for the current system theme, we can call schedulerbinding.instance.window.platformBrightness. This line of code will return a brightness variable that we can use to compute which type of theme mode will be inside the almost emitted theme state. I believe that this line of code should be actually part of the app theme class, so we should create a get method called getCurrentSystemBrightness, returning the current system brightness throughout this line of code. Now, inside the ThemeCubit, we can call simply apptheme.getCurrentSystemBrightness and store its return value into a brightness variable. You have to agree with me, it looks way more cleaner. Now, based on the retrieved system brightness, we'll also have to do two things. We'll need to update the status and the navigation bar colors accordingly, and then we'll need to update the UI by emitting a new theme state with the correspondent theme mode. So why wouldn't we create a private method available only to the ThemeCubit called _setTheme that should incorporate both actions, since at the end of the day that's what all those actions do, set the entire theme of our app. Quick tip, if you don't already know, inside Dart, if you name a function or variable with an underscore, that function or variable will only be available inside the class where you're writing it. It can only be called internally between the functions of this class. And that's exactly what we want. We want to be able to call it only from inside the updateAppTheme method. This setTheme method will take in a theme mode parameter and will firstly call the apptheme that sets status bar and navigation bar colors function with our theme mode, and then emit the specific theme state with the same theme mode. Coming back to our updateAppTheme method, if the system brightness is equal to brightness.light, we'll call the setTheme method with a ThemeMode.light parameter. Otherwise, we'll call it with a ThemeMode.dark parameter. I hope I was really clear and you understood this. So we created the proper functionality of the ThemeCubit, but where and when do we want to call this updateAppTheme method? Well, there's gonna be two main moments. One is obviously when the app starts, and the other moment is whenever the system theme changes. Let's concentrate on the first one for now. In order to run the updateAppTheme method when the app starts, more precisely when the ThemeCubit will be instantiated, we would need to call it in the constructor of our ThemeCubit. Now, since our qubit is tightly linked to the theme of our app, we need to be able to rebuild the entire app whenever the theme changes. Therefore, we should provide the qubit globally in order to be accessible throughout the entire widget tree. So let's wrap our material app in a multi-block provider and provide our ThemeCubit right inside there as our first provided qubit. Now, there are multiple options on how you can rebuild the material app based on the states emitted by the ThemeCubit. You can wrap it inside a block builder, but we know from block 6.1.0 update that there is a much easier way to rebuild a widget built within a context whenever a single property of a block or qubit changes. I'm obviously talking about context.select. So we want the entire material app to rebuild whenever there is a freshly emitted theme state containing a new theme mode input. And we also want to set this specific theme mode value to the theme mode parameter of this material widget. As we know, calling this line of code, namely context.select, taking the ThemeCubit instance and returning the ThemeCubit.state.theme mode, will both rebuild the widget built within the context build context, while also returning the new theme mode variable. So we can directly set the theme state theme mode value to the theme mode parameter of our material app widget. Running the app right now would result in a crash, since the context from which we're calling the select method doesn't contain any ThemeCubit instance. Remember, this context is actually the context in which the app widget was created. The ThemeCubit was instantiated in a context below app's widgets context. So when calling context.select, the lookup for the ThemeCubit starts from the app widgets context above, therefore finding no instance of ThemeCubit. If you don't really understand why is this happening, I invite you to watch my 8th tutorial on block context from inside my block from zero to hero tutorial series. In order to fix this issue, you could of course abandon the context.select approach and use a block builder instead. You could also wrap the material app in a builder widget and use that new builder context, or even cleaner than that, you could extract the material app in a new widget and call it CounterApp. It looks more structured to visually separate the material app from globally providing the blocks or qubits. We'll use the separated CounterApp widget to code the approach for the second moment, from where we'll need to trigger the updateAppTheme method, more precisely whenever the app detects by itself that the system theme has been changed from day to night or vice versa. To tackle this, we need to convert the CounterApp widget to a stateful widget and then add the widget binding observer mixin to it. Widget binding observer provides some native methods called internally by Flutter whenever system-specific parts dynamically change. In our case, we need an observer to listen to whenever the system theme changes. To do that, we'll firstly need to create an observer into the initState method while also not forgetting to dispose it into the dispose method. While the observer is, well, observing stuff, we can override the didChangePlatformBrightness method. This is the method that is called internally by Flutter whenever the system theme of our phone changes. So obviously, we want to call the updateAppTheme method right inside of this method. We can do that by writing context.read of type ThemeCubit, which will access the instance of ThemeCubit, then call the updateAppTheme method on that. Save and restart the app, and now the theme changing feature should work dynamically as it should be. Also, please let me know if you find a more robust way of doing this. It would have been great if there was a platform brightness stream I could subscribe to right inside my ThemeCubit, for example, in order to concentrate all the theming logic in there instead of using widget binding observer inside the UI. So let me know right down in the comments if you know a better approach for this. Well, it's time to move on. You might remember that I want this app to feel lively. I want it to have a moving particles animation as a background. Now here's a lesson I want you to learn really well. In life, you don't have to reinvent the wheel every time you want to do something. If you want to heat up your home, you don't have to reinvent the fire. If you want to take a drive to Paris, you don't have to reinvent the wheel. These patents have been already developed by someone who's been kind to share it to the entire world. The same thing applies with Flutter too. If you're thinking about some complicated feature, there is a high probability that there's already somebody who developed that feature and posted it publicly with a license on GitHub, on pub.dev, or on any other websites and forums. And want me to prove what I said? So I want to have a moving particles background. And soon enough, I found this amazing package called simple_animations that contains a feature called Liquid Studio. If we click on it and enter the editor, you can see that it is more than perfect to what we actually need. And even more than that, it's really customizable. So not only we found our base, but we can also tweak it to our liking. After spending a couple of minutes trying to understand how it works, I managed to get the look that I wanted. So all you have to do is to export it to Flutter code and observe how amazing this tool is. Now, we need to add the simple_animations dependency into our pubspec.yaml file and paste the code into our counter screen widget. Let's do some refactoring because we won't need this title string anymore. Fix our imports and we're done for now. We can save and run our project to see how it looks like. I don't know if you can see it on the recording, but there are some white particles moving in the background, just as we wanted. Actually, let me set this container background color to black in order for you to see them clearly. You can see this is mainly the behavior we wanted, but there are some things that I don't quite like. As you may observe, these aren't the colors we mentioned in the theme we designed earlier, and the background won't even change when the system theme changes. That's because we didn't set them to the appropriate colors. So the container background color should be set to our theme.ofContext.background color, and since we have set theme block to change the theme mode dynamically, Flutter will be able to decide whether it will pick the light background color or the dark background color from inside our app_theme class for this feature. But what about the background particles color? We can't simply call theme.ofContext.particles color, since the theme data is a predefined Flutter class containing its own predefined fields like primary color, accent color, and so on and so forth. These were the default colors we overridden inside our app_theme class, but we can't simply add down another field like particles color to the theme data class. Or, can we? Is there a way we can extend the already predefined theme data class with custom fields? Thankfully, there is a solution to that, added with Dart 2.7.0, and it's called extensions. Extensions are basically a way to extend an already predefined class. So in our case, we can write down outside of the app_theme class something like this: extension plus the name of extension, which in our case will be theme extras, plus the keyword on, plus the class we want to extend, which in our case is theme data. Inside of this, we can say something like color get particles color to return the appropriate particles color, and since we have a light tint and a dark tint, we need to let Flutter know which one it will return. So if the brightness is equal to brightness.light, then we'll return the light particles color. Otherwise, we'll return the dark particles color. And that's how you can basically create a complete custom theme for your app. I always do this separation because I like using some default colors from inside the default theme data while also extending it with some of my extra colors. Now, coming back to our counter screen, we can write theme.ofContext.particles color for the color of our particles. Don't forget to import the app_theme.dart file here at the top, otherwise Dart won't be able to know the particles color field and won't even tell you that you can automatically import that file. If we finally save and run the project, you can see that whenever I change the system theme from day to night mode, the entire app changes completely. And coming up to my initial idea, imagine how much time it would have taken you to achieve an animated background like this. So huge thumbs up to Felix Blaszke, I hope I pronounced his name right, for developing this amazing package. We'll use simple_animations on probably all of our projects from now on. Okay, moving on, I need to say that I really like modularisation when I'm coding any apps. Each screen should be split up between its skeleton and the component widgets found inside the skeleton. What I mean by that is that inside the counter_screen.dart file, I like keeping the skeleton of the entire screen, and that inside of the widgets folder, I like keeping all the widget components found inside the skeleton of that screen. So, in our case, we want to extract the plasma background as a separate component. And we know that whatever widget will come next will be rendered above it. A perfect widget for this behavior is the stack. So let's wrap the entire plasma background within a stack. There we can see that the background will be the first layer of this stack. So why not extract it as a separate widget or component called plasma background. Now we can create a separate file inside the widget folder called plasma_background.dart and move the widget right over there. We can fix the imports and delete the counter_widget.dart file since it was just a placeholder. Now you see what I mean by modularization. In a huge project, this will win you big time, because when you want to modify a part of a page, you'll navigate to the page, find the skeleton, and then click on a part, then see what you want to have it modified later on. Speaking about modularization, why don't we add the next component of the counter screen right to the skeleton? I'm of course talking about the CounterSlider. Somebody will have probably coded this before, so why don't we go and grab the code right from the source? Then we'll create a separate component file with a widget called CounterSlider.dart, inside of which we'll paste the entire code. So let's position it temporarily on our home screen. On a stack, if you want to position something relative to the corners of your screen, you can use the positioned widget and specify how many pixels you want to be between the corner you chose to your widget. In my case, I want the slider to be 48 pixels from the button. You don't have to worry about responsiveness for now. We'll get to it later on. Also, don't forget to mention the alignment for the children of our stack. We want them to be centered on the screen. Now, as you can see, we got the slider on the screen, and I know for now it looks horrible. So let's get to modify it. We'll start by erasing some of the unnecessary parts of the code. We won't need any of these fields. We won't need a value since the counter value won't be displayed inside of this slider widget. The direction of the widget will always be horizontal. The color of the slider round container will be the theme accent color with a 20% opacity. The colors of the icons on the margin will be set to the icon color with a 70% opacity. The color of the main slider button will be the theme accent color. Here, I feel like the button is kind of too big for my liking, so I'll add some padding of 8 pixels to it. Since we want the counter value to be moved somewhere at the top, we'll replace it with an icon and color it appropriately. We'll proceed to refactoring the entire code as we saw. Now, these setState methods are actually where the counter got incremented or decremented in the default behavior of this widget. So this is exactly where we'll call the increment and decrement functions from our future CounterCubit. If we save and restart the project, we'll see how much of a difference some predefined colors make. Also, when we switch from light to dark theme and vice versa, you can see the slider reacts too, and that's perfect. Of course, the size of the widget is a little bit too big for now, but we'll take care of that later on when we'll talk about responsiveness. And as I mentioned in my previous video, I want the counter value to sit somewhere at the top of the screen, while being sublayered by a fancy circular animation. Well, when you want to build or find fancy animations in general, the place you should look for is definitely flare. I want some kind of an animated circular animation, so I searched for the circle keyboard. After a couple of moments, I found this perfect animation. So all you have to do is to check if it can be used inside your app by taking a look at its license. Then download it as a .flr file. We need to add this file to our project, so it's a good practice to create a folder called assets where you can store all these external files. Inside of this folder, I'll create another folder called flares, and I'll add this file right there. In order for Flutter to be able to recognize that file and read it, we need to add the path to our assets folder right into the pubspec.yaml file, just like this. Since we're already into the pubspec.yaml folder, let's add the dependency that will help us display the flare animation. The package is named flare_flutter and you can find it on pub.dev. Now all we have to do is to add it to the counter screen skeleton. We'll extract it as a separate widget later on. So the widget loading up the flare animation is called flareActor and it needs to receive the path of the flr file as a parameter. You also need to wrap it in a container to mention the width and the height it will restrict itself to, let's say, 300 by 300 pixels. Also, the container needs to be wrapped inside a position widget as we did previously with the CounterSlider. This time, I want it to be 48 pixels from the top edge. You'll need to save the entire project, close the app, and rerun it again for everything to work. Surprisingly, the flare loaded up perfectly on the first try, but as you can see, we have a slight problem. It's not animating. Why is that? Well, if you open up the flare inside the editor, you'll see that you can make multiple animations inside of it, and that the current running animation is called alarm. So if we set that to the animation parameter of the flare actor, it will successfully start to animate. We can also give the flare an overlay color, so that when you have a white flare like this, you can easily change its color by modifying its color parameter. I'll set it to the accent color. Now, the widget is ready to be extracted as a widget component. Let's call it Animated Circles. You can observe how clear, simple, and easy to read the counter screen skeleton is beginning to look like. What's left to be done for now in terms of UI is to add the text for the counter value right above the animated circles. How can we do that? Of course, by using a stack. So we'll wrap the animated circles widget into a stack and we'll set the alignment of it again to center. Above the animated circle, we'll have a text widget with a counter value. We'll set its style to headline 1 and we'll add some bold and some different font size by using the copyWidth method. Of course, we need to extract this to a component widget and we'll call it CounterValue. Currently, the app has no counter functionality, so let's move over to developing that right now. You might be already familiarized with how to implement the CounterCubit if you watch my previous tutorial series. We'll start by creating the CounterCubit and then the counter state, which is going to contain the current counter value. The initial state of the CounterCubit will obviously be the counter state with a value of 0. The CounterCubit will contain two methods, the increment and decrement ones. One will take the current counter value, add 1 to it and emit a new counter state with a new counter value, while the other one, well, you know already, the opposite. We'll use the magic hydrated block to store the current counter value to local storage, so that whenever we'll restart the app, the counter value won't reset back to 0. To do that, we'll need to add the hydrated block dependency into our pubspec.yaml file. Don't forget that whenever you add a new package, you'll need to close and restart the app in order for Flutter to update all its files. So, first and foremost, after you added the hydrated block package, you need to set up the storage where it will store the counter states. To do that, we need to navigate to our main.dart file and set up these two lines here before the app runs. Now, we can go to our CounterCubit, add the hydrated block mix into the class, and override the two JSON and fromJSON methods. Since these two methods are responsible for storing and retrieving the counter state from the local storage, we need to make sure our counter state knows how to switch itself to and from a JSON file. So we'll create the JSON serialization by using the Dart data class generator. We'll only keep the toMap and fromMap methods since this is the type our hydrated toJSON and fromJSON methods work with. Now, inside the fromJSON method, we need to make sure that the JSON is not null, because take in mind, whenever you run the app for the first time, there is no data stored on the local storage, and this JSON may be null, but if it isn't, we'll return the counter state object built from the existing map provided right from the local storage. On the other hand, the toJSON method is called whenever a new state has been emitted by the qubit, so that we'll store the most recent value of the counter to the local storage. Whenever it will get called, we'll return the state.toMap function. Hope you understand how hydrated block works. If you want a more in-depth explanation, check out the 11th tutorial on maintaining application state in Flutter from inside my block from 0 to hero tutorial series. So our logic is ready to be put to practice. The next step I'll do is make sure I provide the newly created CounterCubit globally inside our main.dart file. We'll do that by using a new block provider child into our multi-block provider widget. So right now, a unique instance of the CounterCubit is available globally inside our app. After this, we need to switch to the CounterSlider because that's where we will call the increment and decrement functions. Therefore, here where the animation value of the slider is less than the minus 0.20 threshold, we'll call the context.read of a type CounterCubit.decrement, and in the other case, we'll call the increment method. Now, the only thing that's left to be done is to rebuild the text widget containing the value whenever a new counter state is emitted. So, we'll switch our view to the counter_value.dart file. Since this is a standalone widget built within its own small context, we can rebuild it by calling context.select whenever the value of the counter state changes. We are finally ready to test the functionality of our app, so let's save and run the project. As you can see, everything works as it should be. It is time to focus on the latest finishing touches of this project. You might remember from my previous tutorial that I said I want the counter value to somewhat animate whenever the user slides right or left, in order to give him a more visual feedback of what happened. To do that, we'll use the animated_do package, which contains a list of really amazing animations. So we'll go right ahead and add the dependency to pubspec.yaml. I would like to use the zoom in animation every time the widget rebuilds, aka every time the counter gets incremented or decremented. To do this, we'll wrap the text widget from inside the CounterValue widget within a zoom in widget and set a duration for the animation. In order to replay the animation every time the widget rebuilds, we need to gain access to the widget's internal animation controller so that we can call the forward method on it. Therefore, we'll need to convert our widget to a stateful widget, create an animation control variable of our own, and assign it to the internal one by using the controller callback from inside the zoom in widget. Don't forget to dispose the animation controller into the overridden dispose method of our widget. All we have to do next is to set the manual trigger to true, since we did what we did to manually control the animation. Therefore, whenever the widget rebuilds, we'll repeat the zoom in animation by calling _animationController.forward from 0.0, but only when the animation controller is not null. Remember that when the app runs, our controller is not linked to the internal animation control on the zoom in widget, so we can't call the forward method on it, since it's null. It will get linked whenever the method tree is built. If we finally save and run the app, you will see that everything works perfectly. The theming feature switches seamlessly between light and dark, the counter maintains its value whenever the application restarts, and everything seems to be looking nicely done. Right now, the application looks okayish on our phone, but what if we want to use it on another phone, on a tablet, or perhaps on a desktop website? How can we test the application on multiple screen sizes, and how can we actually make it responsive so that it will look amazing on all of the screens? Well, I use two packages for these two jobs, Device Preview and Sizer. Let's try the first one by adding the package to our pubspec.yaml and configuring it properly inside the main.dart file by following the instructions on the pub.dev official page. Now if you save and run the project, you'll see what this plugin is all about. This is what I use to test the responsiveness of my app on multiple screens. Here's what I want you to observe. Currently, due to how we code the UI directly with fixed sizes for the containers, for the text and for the position widgets, the application may look okay on a Samsung Galaxy S20. But what if we switch our device to a Pixel 3, for example, to an iPhone SE, and why not to an iPad Pro? You must admit that our application doesn't look really good in those different scenarios. In order to fix this, we should have our size inputs calculated consistently to the screen. They will be rendered on. The package I'll use for this purpose is Sizer. So let's go and put it inside the pubspec.yaml, save and restart the app as usual, and inside the main.dart file we'll need to wrap the material app within a layout builder and an orientation builder widget, and then initialize the package by calling sizerutil.init with the constraints and orientation we established earlier. Now we need to browse to every widget we have set up static sizing values to, and we'll start with the skeleton of the counter app. Currently, the stack containing both the animated circles and the counter value widgets is set to render 48 pixels away from the top. This is wrong in terms of responsiveness, because what are we going to do if the screen has a height of 10,000 pixels? Are we going to still render it only 48 pixels away from the top? Of course not. We should try a dynamic value. We should set it to be around 10% of the height of the screen. So if the screen is 1000 pixels in height, then the widget will render 100 pixels away from the top. If the screen is 2000 pixels in height, then the widget will render 200 pixels away from the top. You see where I'm going with this. How are we going to write this with Sizer? Well, first of all, we need to import its package at the top. Then write a double value followed by an W for width or H for height. We want our widget to render at around 10% of the height from the top. Then we'll write 10.0.h. If we save the project and check the device, you can notice that the widget moved down a little bit. And if we open up DevTools and select the positioned widget, we can notice that if we switch devices, the height value at the top changes dynamically based on the height of the screen. And this is exactly what we wanted to happen. Also, I like to leave the debug paint option activated so that I can see the constraints of the widgets more easily. So let's take care of the slider counter widget now. I'd probably want it to be the same distance from the bottom side, so around 10% of the height of the screen. Well, 10% looks kind of much. What about 8%? 8% looks perfect to me. And see, there's not always a general rule on how you'll choose those values. All you have to do is trial and error them out and see which one fits you the best. Now let's take care of the rest of the widgets. So currently the animated circles container has a static width and height. I think a fair value for the width will be around 60% of the screen's width, and the height should be around, let's say, 40% of the screen's height. And voila, I think it looks perfect on the iPad right now. But what about the iPhone? I'd say a little bit too small, so why not make it 70% of the total width? Perfect. Now, the only problem here is that the text does not resize on different screens. And that's because, you guessed it, we set it to have a static font size. I think 18.0 SP would look good on that. SP means scalable pixels, meaning that the font size will update dynamically to the screen size. We're done with the top part of our counter widget. So let's move on to the slider counter because we have a lot of static pixels in there too. So let's think about the width and the height of the slider. We don't want to make it really small because the user might not be able to slide it properly. But right now it is really big. So I guess a value of 55% of the width will be fine. And for the height, probably around 10% or less. 10% is too little for the height. Maybe 12? Yeah, 12 seems perfect. Now on the iPad, I feel like it's too much of a stress for the user to have to slide this much. What can we do in this specific case? Well, we can have separate widths for tablets by writing this line of code. So if the device we're showing this app on is a tablet, we'll choose a width of 40%. And if not, it will be around 55%, just to make it easier for the user to reach it. Another little detail we must fix is the icon sizes, again because they are set to static pixels. So I have decided that if the screen is a tablet, the icon sizes should be around 7% of the width, and if not, they should be around 10%. Now, since the app was only designed for portrait mode, we won't actually focus on the landscape screens. We'll take care of those in future tutorial projects. Anyways, if you're not happy with the results of your responsive layout, you can always tweak it a little bit more or less. And we're finally done redesigning and coding this counter app. I really hope you finished this tutorial with a ton of new knowledge. I entered really in depth about some concepts in this video just to let you know how we're going to develop projects from now on. I am really open to feedback on how I can improve these tutorials from now on. This counter app was just an introduction. More amazing projects will come out soon. However, these tutorials take so much time to make, so I would appreciate it if you could like this video, share it with all of your colleagues in pursuit of top-tier Flutter development, and subscribe to my channel. It really keeps me motivated. Until next time, as always, take care, Wicked is out, bye bye.